Okay, so when we're looking at a triangle here, a right triangle, so again, we're still talking about right triangles. Which side is the hypotenuse? Is that BA? Yes, BA is the hypotenuse, or AB. And what do we call the other two sides? Legs. Oops. Okay. Instead of saying side for all of these, I'm actually going to change this to leg. So that is a typo in the notes. I apologize. Didn't catch it in time. Okay, so here's angle A. What leg is opposite angle A? Yeah, BC or CB, yes. Either one is fine. And what leg is adjacent to angle A? See what? What does adjacent mean again? Do we remember? So adjacent means next to. So what leg is next to angle A? We need two letters. CA. Yes. Okay, so this would be the adjacent. Okay. Then from angle B's point of view, what leg is opposite? AC or CA. And what leg is adjacent to B? CB. Okay. So just notice that depending on which angle we're talking about, when we say what's opposite is going to be different from the two angles. They have different points of view. And thinking about opposite and adjacent is going to be really, really important in what we're about to talk about. So in this next part here, we're going to talk about it from angle G's point of view. Angle G there is 23. What side would we label H? H stands for hypotenuse. 9, 40, or 41? Which one's the hypotenuse? The 41, right? Okay. Which one would be opposites? The 9. Yep. And then adjacent would be the 40. So there's opposite, there's adjacent. And we said that measure of the hypotenuse is 41, the measure of the side opposite G is 9, the measure of the side adjacent is 40. Okay. So we're going to talk about some ratios. Remember, a ratio is another way of talking about a fraction, or two numbers, one over the other. And these are all from the point of view of an angle. So the way that we would say this right here is we would say this is the sine of an angle. And so the ratio for sine is from the side opposite, or we'll say the opposite leg, over the hypotenuse. Or the ratio, we could say, from the opposite leg to the hypotenuse. And a lot of times we'll abbreviate that by saying O over H. So that's called the sine ratio. The cosine of an angle is the ratio of the adjacent leg to the hypotenuse, which we abbreviate A over H. And then we have a third one called tangent, which is the ratio of the opposite leg to the adjacent leg. Which we abbreviate O over A. So we've got these three ratios, sine, cosine, and tangent. And the way to remember this is with this abbreviation SOHCAHTOA. So the S here stands for sine, and that goes opposite over hypotenuse. Then cosine goes adjacent over hypotenuse, and tangent goes opposite over adjacent. And so we're going to be setting up a lot of equations with this. And so the equation always goes like this. You have a trig ratio, so that would be sine, cosine, or tangent. That's what we mean by trig ratio. We're going to abbreviate those SIN, COS, and TAN. So that's those sine, cosine, and tangent. Those are the abbreviations. We're always going to have parentheses, and inside the parentheses, we're going to put an angle. And then the ratio is always going to be between two sides. And so that's going to depend on which side is which. Okay. So again, we're going to get into solving some equations, but first we're just going to look at setting up the equations. So for sine of A, so here's angle A. I'm going to look at my abbreviation here and see that, okay, sine is the opposite over the hypotenuse. So that means sine of A is the opposite, which is 5, over the hypotenuse, which is 13. And so I would say that the sine of A equals 5 over 13. Again, this might be a little strange, but we're just talking about setting things up right now. It'll make a little bit more sense once we start solving. So cosine of A would be the adjacent leg over the hypotenuse. So what would that equal? That would be 12 over 13. So 12 is adjacent, the adjacent leg. 13 is the hypotenuse. And then tangent is opposite over adjacent. Opposite leg over adjacent leg. So what would that equal? 5 over 12. Yeah. Nice. Then once we go to angle B, notice now 12 is opposite, 5 is adjacent, but 13 is still the hypotenuse. So we've got a different point of view here. So when I go sine is opposite over hypotenuse, now that's going to be 12 over 13. For cosine, I'm going to do adjacent over hypotenuse. That would be 5 over 13. In tangent, we would do opposite over adjacent, so that would be 12 over 5. So notice that sine A and cosine B are the same thing. And cosine A and sine B are the same thing. That's always going to happen. And then notice that the tangent of the two different angles are just reciprocals of each other. That's also always going to happen. Okay, so now you guys are going to do the same thing. Set up the ratios here using the sides of the triangle, and then we'll check together. All right, so what did you guys get for sine of A? 7 over 25. Nice. Cosine of A? Nice. And tangent A?
7 over 24.
Nice. All right. So then sine of B? 4 over 25. Cosine B? 7 over 25. And tangent B? 24 over 7. Okay, so again, we're seeing cosine A, sine of B are going to be the same. Sine A, cosine B are going to be the same. This will always happen. These two here are going to be reciprocals. Yes. Okay, so here's just a reminder of how you set it up. Trig of an angle, trig function, so this means sine, cosine, or tangent. You're always going to have an angle in the parentheses. And then it's going to be two sides in a ratio. Our abbreviation here is SOHCAHTOA. And that, I would say, it's helpful to write at the top of your paper for all these types of problems. Everybody say SOHCAHTOA. Say it one more time. SOHCAHTOA. SOHCAHTOA. Okay, it's going to be helpful to remember how to spell it. That's really the key. If you spell it wrong, it's not going to help you as much. So. Okay. Now, on your calculators, there's a very important step that we need to do. We need to put our calculator into degree mode. So let me show you how to do that. You see this button here that says mode by the top left there? Press mode, and then you've got two modes that you can change between radian and degree. So right now mine's in radian mode. I'm just going to move the arrow over to degree and hit enter, and now I'm in degree mode. Does everyone see how to do that? Yep. Really? Oh, yeah. We're going to need one of these. Make this calculator.
I'll expose you so heartbreaking and the papers are I did
You can do this.
Hey, Alessandra and Yassi, why do you bring up brain the other day?
Okay. So one day when you're in pre-calc, we're going to learn all about angles in radians. But for now, all of our angles we measure with degrees. It's basically just two different ways of measuring, like Celsius or Fahrenheit. You know, we're measuring the same thing, just different units.
Yeah.
Okay. So here's how we use this to solve for x. So first of all, notice These are not 45, 45, 90s or 30, 60, 90. So if they were, we would not need to do this. We know the rules for 45, 45, 90 and 30, 60, 90. We know how to find all the sides and angles. Also notice we don't have enough information to use the Pythagorean theorem. So in number one, you know, if we have the hypotenuse there, it is true that 5 squared plus x squared equals y squared, but we have no way to solve that because we don't know x or y. So that's not going to help us. So that's why we need to use this. So first, we're going to see that we have an angle. And then we're going to identify what side we have from that angle's point of view. So x, we would say, is what? Opposite. Yes. This is the opposite leg. And 5 is which one? Adjacent. Okay. So which one uses opposite and adjacent? Tangents, yes. So we're going to use tangent. So we have to decide for each one. So I'm going to set up this equation. It's going to go tangent of 25. And I need to say equals opposite over adjacent. So that's going to be x over 5. Okay, so now we need to solve for x. How would we get x by itself? Yes. We would multiply both sides by 5. Okay, notice I cannot multiply this 5 and this 25. That 25 is stuck inside of tangent. What I'm going to do now is I'm going to use the calculator to solve this equation. So I'm just going to type in 5 tangent 25 into the calculator. And so notice you do have buttons for sine, cosine, and tangent. To get out of this menu, you can press second quit. Quit is the same as the no button. I'm just going to write here 5 tangent 25. I'm going to close the parentheses there and I'm going to press enter. Let me know if you have questions on how to type that. Our answer is this number here, 2.3315.
Would we break that all down or like round to
Yeah, so this number goes on forever. So we can't write the whole thing down. And so we're always going to look and see what the directions say. In this case, they say round to the nearest hundredth. How many decimal places is the hundredth? That is 2 decimals. Okay. So our answer is 2.33. Okay, and so one thing we want to do when we solve a triangle like this is, if I look at the triangle, and I see that this side is 2.33, and it's opposite a 25-degree angle, the other angle here would be 65 degrees. So does it make sense that x is shorter than 5, based on our information here? Yeah. Remember, the longest side is going to be across from the largest angle. So 65 and 5 are both larger than 25 and 2.3. And so the way that this works is that your calculator has a lot of numbers and values plugged in, like programmed in, for sine, cosine, and tangent. And so those are just put into the calculator. Back in the day, even before I was growing up, like, you had to have like a chart, like a piece of paper that had all of these values for sine, cosine, and tangent on it. And you had to like look those up. I never had to do that. I always had to graph a calculator. But now those are programmed into the calculator, which is kind of cool. Okay, so for number 2 here, we start with our angle. And from that angle's point of view, what sides do we have? Do we have opposite, adjacent, hypotenuse? We have adjacent, yeah. And we have the hypotenuse, very nice. Which one uses adjacent and hypotenuse? Cosine. So we're going to use cosine. And we're going to set it up as cosine. What's going to go in the parentheses? 55. Yeah, we always put the angle inside. Equals adjacent over hypotenuse. So what would that be? 10 over x. Okay. Solving for x is a little more complicated this time. Do you guys know how we would get x by itself when it's on the bottom? Okay, when x is on the bottom, we're going to multiply both sides by x first. So now I have x cosine of 55 equals 10. So now, because x would cancel out on the other side. And now I would divide both sides by cosine of 55. And so cosine of 55 would cancel out on the left side. So it would be x equals 10 divided by cosine of 55. So it's kind of confusing looking because there's a lot of letters, right? A lot of letters in parentheses. But cosine of 55 is just a number. Your calculator knows it. So now we're going to do the same thing. We're going to take that and we're going to put it into the calculator. 10 divided by cosine of 55. And so that's just going to look like this. 10 divided by the cosine of 55. So that's going to be our answer right there, 17.43. Did everyone get that when they typed it in? Okay, did anyone else have trouble getting that? All good. Okay. So number 3, we have this angle here, 80, And what sides do we have? Opposite hypotenuse. So remember when we say adjacent, it means the adjacent leg. So 10 is adjacent to 80, but more importantly, it's the hypotenuse. So what uses opposite in the hypotenuse? Sine. So we say sine. I know it looks like it says sin. It's not. Sine of 80 equals opposite over hypotenuse. To solve for x, what do we do? Multiply each side by 10. Okay. So x is by itself. Once x is by itself, you just type it into the calculator. 10 times sine of 80. I got 9.8485. You guys get that? Nice. Notice I can write 10 times sine of 80 like that, or I could just write 10 sine of 80 because that means the same thing. Notice I don't have to close the parentheses at the very end, but it's probably good to. Probably should. So 9.85. Okay. Questions on any of that? It's not too bad, right? You gotta remember the rules. You gotta remember SOHCAHTOA. You gotta remember how to set the equations up. But once you get the hang of that, it's nice. It's very straightforward. Okay, why don't you guys give these a try? Solve for x. Ready, set, go. Is so for number 1, do we use sine, cosine, or tangents? Cosine. All right. All right, guys, listen up, please. So we get cosine of 65 equals 10 over x. Okay. So a few more steps when x is on the bottom. What do we do first? Yeah, multiply by x. And then again, this is pretty weird looking, I know, but it's okay. Then to get x by itself. What's our last step? Divide by cosine 65. Yes.
Oh, then water on my paper.
Really? Okay. Once we have x by itself, we put that into the calculator. So we get, what is it, 23.66? Sweet. Okay, for number 2, do we use sine, cosine, or tangent? Sine. So sine of 80 equals 5 over x. Okay, so we have opposite hypotenuse. Okay, so we have to do the same step again, multiply both sides by x. Divide by sine of 80. And what is 5 divided by sine of 80 in the calculator?
Oh, is it 4.2?
No, it's 5.08.
5.08. Okay. We know that it can't be 4 point something because it's the hypotenuse, so it needs to be longer than the legs.
Wait,
So that's
wait.
one leg.
I thought you multiplied the.
Yeah, x is on the bottom in this one. Yeah, 5.08.
So is the next one not?
That seems like a reasonable answer, yeah. I don't know for sure, but it seems good. We're using sine, cosine, or tangent for the next one. Tangents. Okay, tangent 35 equals what?
No.
X over 13.
No.
We multiply both sides by 13, and what do we get? 9.7. 9.10? Yeah.
Yes.
Wouldn't it just be 9.1 then?
If we're doing to the hundredths, it's probably good to leave the 0 on the end. I wouldn't take off if you took it off.
Sure. Same thing.
All right, so now we're going to talk about finding missing angles. Slightly different process here. Guys, listen up, please. So notice X is an angle now. From X's point of view, we have opposite and adjacent. So I'm going to be using tangent. And I'm going to say tangent X equals 5 over 12. And so now I'm going to have a very different process for solving this. What I'm going to do is I'm actually just going to go straight to the calculator and I'm going to type this in. So this is called tangent inverse. And notice that what it's doing is it's switching the 5 over 12 and the x. The way that you do that is you type second tangent. And so that gives me the tangent with this little -1 right there. So it's called tangent inverse. And then when I type in 5 divided by 12, that is my answer right there, 22.62 degrees. And actually our directions say round to the nearest whole degree. So we're going to round this to a whole number, which would be 23 degrees. Okay, so again, we press second, then tangent to get the -1. Any questions on how to do that in the calculator? Okay, so since this one's actually kind of nice because there's no solving. You just once you set up the equation, you can type it into the calculator just a little bit differently. So for number 2, would we be using sine, cosine, or tangent? Sine, yeah, so it'd be sine of x equals 4 over 6. You could simplify that to 2 over 3 if you want. So then in the calculator, we would type sine inverse of 4 over 6. And we're going to round that to the nearest whole degree. Did you guys get 42 degrees? Any questions on how to get that? Nice. So this is actually kind of easier, don't you think? A little bit less work. Number 3, would that be sine, cosine, or tangent? Cosine. So cosine of x equals 10 over 15. So we're going to do cosine inverse 10 divided by 15. Do you guys get 48 degrees? Okay. One thing I want to show you guys. So let's say that I made a mistake and I switched the 15 and the 10. So I typed 15 divided by 10 instead. Watch what's going to happen. My calculator's telling me there's an error, a domain error, which means something I typed in is wrong. It's not going to work. And so that's just going to be a hint for me to say, okay, what did I do wrong? I'm going to look at what I typed here. I would go back and look at the picture and say, oh, wait, that's hypotenuse over adjacent. I need adjacent over hypotenuse. And so I would go back and fix it. So if you see an error, it means you typed something in wrong. That's a hint to go back and check. Okay, you guys do those in the next 3. And that'll be it. Yeah, I don't know who they're playing.